Right, my name is Will Pacheco, and my teammate Robbie Stoho, and this is our video presentation for our Project 2. All right, introduction. So we sought out to answer 3 research questions from 4 different data sets in Gapminder. Question 1, of the countries affected by epidemic, which had the highest rates of death? Question 2, how does the sanitation and water access of each country alter those affected by epidemic and those killed by epidemic? And 3, ultimately, does the GDP of the top countries killed by epidemics seem to be affected? If you notice here, it's important to understand the definitions or where the data sets are imported from. And this table talks about just that.
In the first question, we have of the countries affected by epidemic, which had the highest rates of death? So here at the top we have a table depicting the top 10 countries that had the highest death rates and their corresponding affected count. So each of these are counts for each country for the top 10 killed total. Just below that, we were able to create a summary of each of those. So 7,648 of those were killed, and we have our correlation coefficient at 0.855, which shows that we have a really high correlation, obviously, because you can't really die of something that you're not infected by. Going down, we were able to plot that out using some bar plots. The left side represents the top 10 countries comparatively with their kills, or the kill count, and then to the right of that we have the same top 10 countries, and here we've shown the effective count or affected count for each country so that we can see a comparison with each. And we see that on the left side here we have 2 fairly high outliers in Afghanistan and the Congo Dominican Republic. The others stayed fairly close to each other in range, but those 2 being the highest. Then we have a pretty interesting spread on the right, as we have some like the same Afghanistan and Congo Dominican Republic a little bit higher up, but with a lower range with the Congo Republic in general, and then a fairly even spread with Malawi and Nigeria, or even the United States.
All right, so question 2. How does the sanitation and water access of each country alter those affected by epidemic and those killed by epidemic? So you can see in our first plot here, water access percent as a function of epidemic affected on the x-axis, with the size of the bubble being the percent access to sanitation. Now, if you go to the graph on the right.
So with the graph on the right, we were able to put in a linear model to depict the correlation with water access percentage and epidemic affected. Another thing that's important to note is that the sanitation access percentage also gives you an important piece of information, with the fact that you can see as you go from top left to bottom right, the spheres get smaller, or the circles get smaller and darker, to make it clear that there is also a correlation between sanitation access percentage and epidemic affected. And if we were to put a linear model to that, you would see that it's an even sharper incline than that of the water access percentage. As we go down, we were able to determine linear model using a linear model formula. We see that information set up here. And here we were able to generate a couple examples or fit models so that we could be able to predict what might happen under certain situations. And we use that by creating a third fit model with a variable that we created. And as we see in the chart below, we were able to plot that out using a dot plot. So here we created for our single variable the water access percentage at 50, and we were able to see a range of the variables that could have come out of that, though most of them clustered around 63 to 64,000 in count.
All right, our third research question, does the GDP of the top countries killed by epidemics seem to be affected? And so for GDP years, 1992 to 2007, to kind of get a range for our plot here, gross domestic product as a function of top 10 countries affected for the graph on the left. The graph on the right is a density plot that actually included all the countries from the data set, which had much more data to get the density plot. So you see there were some very wealthy, African countries represented over here.
So with that though, we see that there are a low number of, and actually they're not as wealthy, but with African, there are a lot of areas in Africa that have a low GDP, and that's why we have the huge spike. But as we see with like Oceania or the Americas, there's a little bit more of a spread to that. So the density plot doesn't peak as high, and we see the width spread a little bit more. So this allowed us to compare our GDP of total to the GDP for each of these 10 countries to see with the fluctuation kind of how they compared to the counts for death and affected for epidemics.
All right, so in conclusion, we were able to determine that water sanitation access to correlate with the countries affected by epidemic and GDP count, though something that we might be able to connect to sanitation water condition wasn't quite as affected by the epidemic periods themselves through our data. The takeaway, the death count of the top 10 countries had a good deal of variation while the affected count was easily comparable. Though the average water sanitation access percent had a low correlation coefficient to those affected, there was still enough to determine correlation. The higher the water sanitation access percentage, the less likely affected counts will rise. And then finally, the GDP variation during the multi-year period of the top 10 countries killed by epidemics didn't change as much as we'd expected.